4 views on the trader. Found it.
Yeah, it's there.
Okay.
We're live. And let me make the post and then we start.
Yes.
Right. Done.
Send it to noises as well.
Yeah.
Okay.
Okay, then should we start?
Yeah, alright.
All right. Welcome everyone. Today we're gonna present our INCAR skill stack from INCAR Robotics, which is a spin-off startup from KTH. And our goal is to make these pieces, together with our skill stack, do an autonomous task before the day ends.
Yeah.
And yeah, my name is Michael, and with me I have Jonne.
Yes. Yeah, so I mean, we have a timer running just to show, like, you know, whatever happens will happen. So we think we can do it, and
Yeah, and then we
Can
see
get
how
started.
that goes. So we have Realman robot here, we have Inspire hand, we have a Realsense camera, and we also have a basketball
yeah.
setup. So the skill
With a
we're
tennis
gonna
ball.
doing is putting the tennis ball autonomously into the net, onto the game field. And we're gonna start with setting up the robot
robot.
itself.
Yes.
So we're gonna mount this on the side here with these clamps.
All right. One clamp. And then I will just go look for the Realman documentation in the meantime, so we
Yeah.
can see how to
So
connect it.
we're gonna mount the end-effector, the Inspire hand on it, and we have to also calibrate and connect to the robot. So, and for that we also need to connect the Ethernet cable first.
Yes.
And also boot it up.
Yeah.
So,
So
I'm gonna do this first. Yep.
just for the information of what we are starting out with here on the computer side. I have the metacasting open because we will be using a headset to control the robot, and then we can show whatever we need to show from within the headset. For the rest, this is a new account. I just have here the stream kit so that we can stream this, and the license that we will need. For the rest, everything fresh. So let's see, Realman documentation. Let's see, hardware preparation.
So, I started the robot.
Alright.
That should help.
Yeah. Quick installation base. I mean, we put this wiring. We need to. Oh, you already connected the power supply and the Ethernet you connected.
Yeah, so the robot is on and connected, so we should be able to log into the interface.
Okay, let's see. We need to. Oh wow, fancy. We need to configure our network. Let's see. This is.
Coming alive.
They have a Ubuntu as well. Okay, it doesn't seem like it's, but 2.168.1.100 255.255.255.0 and then 192.168.1.1. All right, let's see. Apply, and then okay, should be this IP. user passwords 1, 2, 3. Great. Let's see. Yeah, so the Realman is Chinese, as you might have seen from this.
Let's first change the language.
So we have used this robot before, so I might be able to find some of the controls, but yeah, that's...
And the first thing we have to do here is to actually calibrate.
Shall I see if it moves?
The end-effector, yeah.
I mean,
you can go and see that it's...
zero pose.
Yeah, this is good.
Okay, initial pose. Maybe I can... no, zero pose would be a bit high.
Well, this is nice to mount.
Okay, alright.
The hand. So we are mounting the hand with a custom camera holder, but the rest is out of the box. So we're gonna start with that.
Alright.
Mount it on here first. Just need to find the right orientation for this. And then the camera looks like on the back. Yep. So the Realman comes actually with a direct integration of the hand. However, we're not gonna use that one and kind of integrate the hand as if it would be its own robot.
Yeah, because we like it when you can use whatever hardware you want. So if you would have another hand, even if it doesn't have a Realman integration, it doesn't matter, because then you can still use it.
Yeah, or if you have another robot.
Or if you have another robot, of course. Yeah. Yeah, I mean, I will touch on that a bit more once we actually get started on the software side. Yeah, so actually, maybe I can already go and go to our documentation. So we have our documentation here. I don't think we need this. All right. So people often wonder what do we actually do. So basically, we do exactly what we want to showcase here today, which is we want to make it as easy as possible for anyone to start teaching robots, deploy skills, teleoperate. Is it?
I mean, it's a bit misaligned, so I think we have to move this guy actually one over.
Okay.
It's okay. You can continue with the setup.
Right. Yeah, so we want to make this as easy as possible for anyone, and that's what we have developed our software for. So I'm just gonna go through the install instructions. See, open the terminal. So yeah, like I said, I did already download a license so that this works. You would get this over mail, but for the rest we can just follow the steps. So let's see, we need Python 3.12. I think on Ubuntu, Ubuntu 24, this is standard installed, so that is all fine. And then I'm just gonna copy paste these instructions, and this should install our system. Yeah, so I mean, this will take like a minute or two depending on your internet speed, because this will download all Torch and CUDA dependencies, which can be quite large, as you can see here. Let me actually make sure that I have big letters here. Yeah, so installation is really as simple as that. Yeah, now we wait while this installs. Maybe I can help out Michael with the mounting of the robots.
This looks better.
Yes, alright.
So, very good. So, because we are not plugging it directly into the Realman, we do need to actually calibrate what the robot has as a tool configuration once it is actually mounted on it. All of it.
Yeah.
This one is a fun one.
Should I go to the other side? You manage.
Be fine.
Alright.
And I think we can also mount the
Camera.
camera right away.
Let's see. Do we want the cable on this side?
That's fine. Alright. Great, so that setup is done.
Let's see then. Probably want to.
So to configure the tools, we can go to hardware, getting started, hardware preparation.
Getting started, hardware preparation. This is where we were, right?
No, hardware teaching user guide. Let's go just through it. It should be kind of calibration of end-effector somewhere. Yeah, here it is. Okay, and we can do robot arm configuration.
Okay, yes.
And now we can go downwards. Keep going down. It's quite a lot of stuff because this is we did.
I mean, this we already did. Yeah.
Yes, so it's just coming as the next step behind there.
IP mode setting, robot configuration. Okay.
Exactly. Configuration, robot arm configuration, tool calibration. Now let's make it bigger.
Okay.
Tool calibration.
Yeah, security configuration is not.
So as we can see, we already have the hand configured, but we will gonna reconfigure it freshly from here. So we can go do it manually, and yeah, this is kind of where the tutorial says it. We will not do the tool calibration with the dot, and we also kind of try to get the hand middle point as the new end-effector frame, and this is approximately 110 millimeters away towards the set of the tool frame.
All right.
So now we can add the mass. We know that this hand weighs around 675 grams, so that's what we're gonna put in there, and then we can do calibration start, which will make the robot move and basically auto-calibrate the center of mass of the end effector.
All right. Let's see.
So now it goes through these predefined motions,
So
and then calculates the center of mass
let's
automatically.
see. I will actually focus on
For us.
us. Yeah, I am doing it. Yeah.
So careful to not get into the way of the hand.
Hello, hand. Wow.
So this of course adjusts the internal controller. When the controller knows how heavy the end effector is, the controller obviously performs much better. So this is a quite needed step if you add any creeper end effector that weighs more than half a kilo or so.
Yeah. All right. Calculating.
All right. Yeah.
It seems done. Yet found the properties.
Looks good.
I'll
We can
edit.
add it.
And then I will select it.
And we can bring back the robot to our initial pose. With the, you still have to select the right
The Inspire.
end effector. And we bring it back down. And then we can mount the rest of the cables.
Maybe that's handy.
So we have two cables. One is the Realsense camera. And the other one is the Inspire hand.
Power supply.
Cables.
USB.
Which we add to our USB-C.
Oh. Apparently your PC can go to sleep.
Yeah, I can plug it in.
Alright.
Okay.
Okay, then maybe let's tape this so that, let's see here tape, or
Let's give it enough slack.
this is fine, right?
We can move
A bit more?
just to be on the
Safe side.
side.
Oh, sorry.
Tape it onto the robot. Enough. A bit of slack, and then we can take it one more. Yeah. Still here. We have enough slack in the cables, so when the robot moves, it doesn't rip out.
Alright,
Great, and then we can set
up our scene.
the field, right? Something like this.
Alright.
And plug in the hand.
And then I think we...
With this, the hardware setup
Yeah.
is complete.
I think so.
Nice.
Then we get to the
18
interesting
minutes,
part now.
yeah. So hardware setup. So now it's about making the robot smarter.
Yes, alright. Well, let's see. This seemed to have installed. So now we get to the fun part. Running the INCAR stack. You're right, I should, let's see, put on the screen. Okay, so the command seems quite simple. INCAR run. Let's see, and like it says here, in the first startup, I will be prompted to download the latest GUI, which
We want.
I want the GUI because I want an easy life. And then once the GUI starts, I should put in the license key. Now, before you get all too excited, the license that we have here is only valid for 1 day, so it won't help you out a lot, unfortunately. But if you want one for longer, then you can of course visit the website.
Very good.
Yeah.
So yeah,
All right.
there we are in the GUI.
Seems like this works. I will go to the first steps. So first we have already INCAR running, and then we will be using a VR input. If you have other inputs like mouse, gamepad, space mouse, also fine. But we find VR input the most, intuitive. So I will go with that. Then I just launch the commander, and this opens QR, and it says to open teleop.incarrobotics.se on the VR headset. Well, that is nice. And this is also why I have the casting here ready, so that I can...
You will be able to see what the headset sees.
Yes. Let's see. Let me start casting. Okay, so this should at some point.
Oh.
Uh-huh. All right.
There we are.
So, hello. So, I need to go to a browser, which comes standard on the headset, and then I can just go to teleop.
Yeah, so there's no need to install.
.incarrobotics.se. So nothing needs to be installed here. This headset goes out of the box.
You still have to make an account to use the headset, but you don't need any developer account or install any app on it.
Yes. All right, so I can scan the code. Oh, that was really fast. And then continue. And now I can enter XR. And as you can see, I now have a coordinate frame on here. I mean, I know the documentation out of my head, so I will just walk through it. Let's move this a bit out of the way. So here, this coordinate frame, I can calibrate to the robot by pressing A plus B. And now the controller vibrates, and I hear the sound. And this way, we can align our controller with the robot frame, so that this is, yeah.
So it's also not limited to single arm usage. You could use the other controller as well to control a second robot, to do a bimanual control. And also, you can adjust the frame however the robot is mounted, and it's best for you to control it.
Yeah, so also note I don't need to wear it anymore now, because I've already calibrated. And actually, let's validate first by starting the robot dummy. So I will open a new terminal. I have to source the environment, and then I can do INCAR robot dummy. Let's see. So now we have a robot dummy here, and it's set to connect using the local host IP in the robots window. So if I do this and I open connection, let's see if this is connecting. Connection successful. And now I can move the robot up, down, to the right, to the left, forwards, backwards, rotations. So it seems like installation is successful, I would say.
Mm-hmm.
And you can even see I'm already starting to receive state from the robot dummy. Yeah, so controls, yeah, I mean, you can read those in the documentation. They are all on these Quest controllers. There are some buttons. Let's see, setting up a workspace. Yeah, so a workspace is basically where you can define your project. So this is where you can save or collect your data sets, collect your policies that you're training, and do some configuration so that if you have various projects, you know, things don't go all through each other. Like,
so we kind of recommend to have a workspace for one physical setup. So if you have on one computer but you have multiple robot setups, it's good to have another workspace. If not, if you only have one robot and one setup, normally one workspace.
I'll call this actually the stream workspace. Does not exist. Would you like to create it? Yes, I would. Yeah, so I will actually close here, and now you can see this actually created a folder in the home directory now where I said, "Oh, welcome, thanks." No, I don't
First time starting on this account.
Yeah, no, I don't want. Yeah, yes, I trust. So yeah, like you can see, datasets, policies. And the config. It is on the roadmap to make this config GUI accessible, but don't worry, it's not too complicated either. So yeah, now I think would be interesting to get our own robot to move.
Instead of moving the dummy.
Yeah, so we already have a Realman integration. In case you don't have your robot in this list, it's really not too complicated. I will explain this as well. But I will explain it with the existing thing. This link needs to be updated, I think. Oops. So yeah, let's see. We need to have the following packages. Robotic arm is the Realman package. They called it robotic arm because it's a robotic arm, right? And let me actually, can I just get this pop-up gone? Then I can clone this.
So this one is also open accessible, so you can actually follow this step exactly.
I mean, I'm not logged in, indeed.
How it is, because there's no GitHub account logged in on this user.
All right, and we have the Inspire hand, so I will also do these things. All right, and then it should be quite easy. Python 3 run. I think this path should be. Of course, I didn't clone them in the in my extensions. I mean, it doesn't matter where they live. Just I like to have a structured project. Okay. See, Realman Python 3 run.py. Let's see.
So this one starts now on this IP.
Yeah. So now we can.
Which we need to connect.
Get here.
So instead of localhost, now we are connecting actually to this robot.
185. Open connection. I will also increase this a bit. Alright, so now it's connecting, and now I will swap back to the scene. So now I calibrate the hands, and I use the same controls, and now I can
already teleoperate
the robots.
30 minutes.
Yeah, I cannot use the hand yet, because I mean I'm just running the robot now, but it's pretty nice. Rotation working. All good. Yeah, so maybe for a little bit of context, what is actually happening here? So I have this this run.py, which is a really simple script. You can just import the INCAR robot interface, and then you set up some command hooks. So if we check here in the outgoing messages, we have a couple commands that are sent out by the INCAR system, which come from. Oh wait, let me actually put on the screen. I'm a very proficient and experienced streamer, as you might notice. So yeah, from the controllers, we are getting some commands, like the velocity, the gripper opening, closing, and in here we can hook into these and forward the command to whatever robot callback. And this is then the only part of integration that you need to do. You need to have a robot interface that can actually receive this. So this, we have it existing for the Realman already because we have done this before, but we can also see for where is I closed the docs.
So in general, it's basically as long as the robot has a decent Cartesian streaming interface, the integration with the robot via the INCAR interface is very straightforward. Yeah, we can look at the UR example.
So yeah, the UR example here the UR is a very nice interface. You just initialize the interface, and then it has a speed L, velocity streaming. You have to take care of coordinate frame. All robots have a slightly different coordinate frame, so that's why we swap some minus signs here. And then for the rest, this is how you teleoperate the UR robot. That's literally all. So we hook up the velocity here with the Cartesian velocity callback, and the gripper with control gripper callback. So if you can set up this for your robot, you will be able to move it. In our experience, doing this takes like a day, maybe, if you have a slightly complicated robot.
It depends very much on the robot manufacturer, of course, what they provide and how well the documentation is and how much they guide into teach panel or whatever. But most modern robots have now these interfaces that are quite straightforward to set up.
Yes. So anyways, I mean, we have our robot. We can teleoperate it. We also wanted to use the hand. For that we have a run with Inspire hand. So let me actually run it with Inspire hand.
Dependency.
Let's see what is going on here. Do I not have Inspire extension? Oh, that's here. Huh. Why is that giving issues? What did it say? Let's see. Module means.
Oh, but do we have the robot interface from?
Okay.
Like for the Inspire. We installed already Realman, right?
Robot interface. That does not install correctly. I will just install it again. Okay, maybe it just was not installed correctly. Let's see. Run with Inspire hand. Right.
Yes.
It's a new account.
So it's a new account.
Add myself to user group. Let me see. I never remember that command, but it's the first Google thing. Still using about this, but I think I will go for this one, because otherwise I need to log in or log out and log in, and then I need to stop the stream. Alright, invalid password. That's interesting. Is there a caps lock on or something?
Can do sudo sl to ls to see.
Oh.
Yeah, so it doesn't ask for the user password, it seems.
Do I first need to do this and then
Yeah. Let's see.
Oh, okay.
Yep.
Okay. All right.
Good.
Okay.
So now,
New shell. So I need to
yeah, source the environment again. Yeah.
INCAR activate, and now I can. No, okay, it is really a new shell. Okay, Python run with Inspire, and
Huh, it moved. It's alive.
let's see. We open the connection again. I want to swap back to the camera. So let's see. This works, but of course this is a left-handed robot. So if I'm correct. Okay, this is no problem. From this we can just inspect what we are trying to see and what is actually happening. So if we go to the run with Inspire, and we can see we are listening to write.commands.arm.ee.velocity. We have that, I mean that's working. And we are listening to indeed left.commands.hand.inspire because it's the left thing. But as you can see, swap back. Oops. As you can see, we don't actually send this out as a command. So I mean, of course, why do we expect it to move? So you might wonder now, how do we get it to move? So we do have some examples for hand teleop. And basically, this is where one of the strengths of the system comes in, because it's extremely easy to write your own extensions, which can take whatever inputs you have and process it to become new commands, or to process it before you train something, or before you send it as an observation into your inference. So we can write a very small extension that basically can take like a gripper input, which is the button on the front of the controller, and take this and transform it into a hand command, because a hand needs to know
So this is a sixth of hand with different joints, but we want to use it as a normal gripper to pick up the ball.
Yes.
So that's where the extension comes in.
And luckily, this is already for the Inspire hand. It's already existing. So this is for the for getting kind of a gripper out of this hand. It's this simple. We inherit from a process step class. This is also all in the documentation, by the way, if you want some more time to look into it. And we just process a single frame. We hook it into teleop commands and inference commands, so that also like the inference can also do this transformation, reusing the same code to avoid any errors in mismatch. And then basically, we
basically predefined the pose of some of the finger
yeah.
joint positions as with the angles here.
Yeah.
And then by pressing the button, we basically transition from open to closed pose.
Yeah. So we get a frame. This frame consists of like our gripper feature, and then we can just create a new frame with the out key, like the Inspire command, for example. And this populate this with a pose consisting of the joints. So I'm just gonna make one that we can then call Inspire gripper basketball pose. Basketball pose. And as is also pointed out in the documentation, we need to import it here. Basketball pose. as it says here, make sure to import it in the init. And then we can just add it to the command processing in our workspace config. So remember this config, there's a bunch of stuff pre-configured like limits, gains, etc. just to keep it a bit safe. But if you want, I mean, you can do whatever.
Free to edit.
So in this command processing, we can add one of our type. Let's see, how do we call it? Inspire gripper basketball pose. And that's all.
Again, the philosophy is that this is the workspace and the hand, well, belongs into the workspace.
Yes, so I will restart now. There is actually some hot reloading that can be done, but whenever you add a new step or new component, new extension, you have to restart it. It's one of the limitations. So yeah, I can... oh.
You went to sleep.
Yes, I will just scan the code again and connect again, and then I can calibrate. Alright, so now when we start the robot, we wait for it to be ready. Alright, awaiting connection, we can connect to it. Let's see, so we can now, actually I realize as well, maybe we can just make it actually use the right hand as well. Because, I mean, for your actual hands it's handy to, to use the correct hand. But if it's a gripper anyways, then it doesn't matter. So yeah, all I did was go for the right Inspire command. And as you can also see, yes, or yeah. So here now, actually, I hope it's not blocked by the camera. So here you can see we now have a write.commands.hand.inspire that we're sending out because this extension is loaded. So let's see. And now that we're connected, if we go to the robot now, yes, we have a gripper. Maybe we can bring the camera a little bit closer because I think the hand is
Okay. Yeah, this is possible.
Is not very visible. It blends in a little bit, I think. Yeah. Alright, so now you can see I can control this. And like I said, we have hot reloading. So, you know, let's say I'm developing this extension and I need to tune some values. So let's say my open pose, I want to change the joint actions. As you can see, the for the Inspire hand, the range is a bit interesting, but now it's hot reloaded. So now the pose is actually different for
so
my open position.
The other fingers are now also open, and for close they go all the way back.
Exactly.
But we only want to pick up with 3 fingers, so that's why we have it, that the initial pose is the 3 fingers and the 2 fingers we don't use are just maximized to...
Yes. Yeah, I think actually I hot reloaded again. I think this pose is actually not too bad, so...
I think that should work too. I mean, you can try picking it up, right?
That is a very good one, actually.
You can see if this pose actually works.
Seems pretty alright to me. So yeah, I mean, now we can teleoperate both the hands and the robot at the same time. And yeah, I mean, as you can see in our interface, we basically combined the different modules, the robot, the hand. Could be that you have 2 robots with 2 hands and a mobile base. I mean, these are all just separate modules that you can assign their own command key to listen to. So yeah, whatever setup you have, it's you can configure it. All right, let's see. So, I mean, we can teleoperate now, but we also do want to actually get the video out of the camera so that we, you know, have some image that we can diffuse to. Let me swap back to the screen again. So let's see. We're in the getting started.
Check the doc.
Teleoperate the robot. I mean, we went through this. We went through how this interface kind of works. Retrieving state. Also here, good to know, like publishing state from the robot is also quite easy with a couple simple functions. And as you can see, then they appear in your incoming messages. So we have arm joints position, arm pose, and we get from the hand, we get joints position and joints effort. So this is all being streamed by via these things. So for the robot, we here set state, which basically, like here we read the joint state, we get positions, quaternions, whatever, and then we can set the state via the module name, which is defined here as a standard as arm. And then automatically we get an arm EE pose, because that's the type that we have. But besides robot state, we also want camera streaming. So cameras, again, we can find in the workspace config. Maybe you already noticed it. Let me actually make this a little bit bigger. And this can be a little bit smaller. So cameras, so there's a couple cameras again that already exist in their own extension, but if you have your own camera, it is quite easy to make your own camera. So I mean, we have this in the documentation. Here is an example of extension for an oak camera, which is like I mean, it's another camera that runs some
we have it.
Yeah, some embedded AI as well. But this is really all there is to it. Like you just need to like make a hook that can provide the next frame somehow, and be able to initiate the pipeline somehow. That's it.
Yeah, so it wouldn't really matter if we would use the oak or we're using the Realsense. In this case, we are going to use the Realsense. It's a more common camera, more people have. But again, you can easily write your own setup for whatever camera you have, including simple USB cams using OpenCV and not any SDK.
Yeah, OpenCV is also standard offered. So yeah, let's see. We have this one. I will call it wrist cam. It's a Realsense. The serial number, I don't know. I will leave it empty for now. We have exposure, white balance, width, height. So it looks good, but I will just go for RGB only. I think that is enough. And as you can see, you can add multiple cameras if you want, but let's just start with one. So I will reload the workspace. And it looks like we got an error. Realsense not installed. In order to use the Realsense camera, please install it using pip install Realsense. Oh, that's yeah, sure. Realsense 2. Pip install Realsense 2. Let's see. Streaming stays bin. How was it called? Ah, wait, of course, source INCAR. That's how our environment is called. Pip install pi Realsense 2. All right. Let's just try reload again. We didn't provide any serial number. Let's see what we have. Also, let's check that this actually works. Always good to verify your hardware. I mean, this seems fine. Let's go info. Here we have a serial number. We'll put it in here.
Great.
Let's turn this one on off so that we don't have the device being busy. Set workspace. No errors this time. Okay. No. Device is busy. Okay, maybe I just need to
Kill the Realsense viewer.
Let's try one more time. All right.
And here we are.
There we have it. So yeah. All right. Okay, now I think we have everything. We're getting our state. We are having a camera connected. Now we can just record a dataset. So here in this dataset panel, we can create one. And now we can select from all our fields, all our features that we have. So I will just record, why not, as much as we have, and then we can see what we do with it for the policy. So end-effector pose, sure. Joint positions, sure. Joint, hand joints. Pedals and left buttons we don't need. Right buttons we will use. That's literally just all the buttons that are on the controller. We don't have any base commands that we need. Right velocity commands, right gripper, open, closing.
It's always good to record more than less, because you can always ignore it when you train a policy, but it's very hard to gain data you didn't record in the first place.
Exactly. The Inspire hand I will not record because it results directly from the gripper open closing. If you would want, you could record the Inspire joint actions and train on that. However, in this case, that would just be more state, which
just makes the life harder, so no need for that.
But let's say you are actually controlling it with your hand, because that is also possible to do hand tracking. It might be better to record the joint actions instead of the Cartesian pose of all your hand digits. I mean, you can select it if you would want. Routines. Didn't touch on routines yet. I will record those as well, and I will show what they are.
Explain them, yes.
And of course the visual feature. And I will call it basketball. Save. All right. So routines are quite a nice feature, I think, which let me show on here. Because, there are tasks where you want to just teleoperate because, it's easier to do freehand motions instead of some scripted things. But there could also be parts that are very difficult to teleoperate. Think of unscrewing a bottle cap or something like that.
Or even doing a straight line.
Even a straight line, yeah. I will have noise in my line, but robots can do this with millimeter precision. If you know you are going to have a task where part is going to need to be learned, but one part specifically you can hard code, you can make this a routine and then trigger it, and also teach the policy when to trigger it. Because it's basically a button input, which is like a Boolean signal, yes or no, that can trigger this routine to be executed. So I think on the Realman, there's one routine predefined, which is just to go home. So if I trigger this button, it will...
So these go home or
Go home.
waypoints are also quite strong, because what they effectively do is they create a bottleneck in your trajectory distribution, which also cuts down on the horizon of the task. Because basically what the underlying policy now has to learn is two shorter tasks that always bottleneck in one defined state. So also it makes it much easier to reset the robot.
Yes. All right. Yeah, I think honestly, like we have all that we need.
We double check if the end-effector is on for the compensate in the Realman.
Ah, yeah, maybe I can. Where's the?
You kill it.
Maybe I killed it. Ah, no, we put it in a different.
Different browser.
Yeah, Inspire, tool calibration.
Yeah, clutch that and then leave it like that.
All right. Yeah, because we want to use our calibrated one, of course. All right, let me just check if I didn't forget to do anything. Collecting data, we created our data set. Yeah, I mean, then I think we...
It's great. First a short demo, and then we will inspect it to double check that we actually have all the features for the policy.
Yeah.
That's a good practice to do before you commit to collecting 20 minutes of data.
All right. So yeah, here I go. I can trigger quite easily starting and stopping also with these controllers. The whole screen now turns red, indicating that we're recording. And yeah, I will just grab a basketball, drop it. I will trigger the routine to go home actually, and then I will save it again. Screen is now gray.
We have one recorded demo.
One recorded demo. So remember, this was kind of the workspace, right? Where also the data sets are saved. So we have dataset basketball. We have the config automatically created. And this demo with all the features. So for example, we have the wrist cam, which, yeah, I mean, this has the video of picking up this ball and dropping it. Seems pretty good, I think. We have the routines. I need to...
Yeah, the inspector stage 5. Yeah, so the good part is that the dataset basically just is on your disk. So if there's a way of also discard the data before you even save it. But if you saved it and you think it shouldn't be in the training data, you can simply delete it from your disk. So it's not packaged into anything. And you can also use it for if you want to have another inspection suite or another tool that needs this data, you can easily connect it to the data because, well, it's just files on the disk.
Yeah, exactly. So yeah, here you can see this is like how a routine looks like. It's just, we only have one routine. You can have multiple routines, then you would have more dimensions in your vector. Now we have one dimension, and it basically over time just has one moment where it triggered. I mean, we have like the arm joints, for example, like yeah, here over time, all different joints. So yeah, I mean, this is yeah, basically the data set. And then, like I said, we also have the buttons. So the buttons are basically yeah, they are a JSON dictionary. And this can be very useful, as we will see later, to yeah, start and stop, or like filter your data based on where you actually moving the robot.
Yeah, because the data set starts recording the moment you press record, but that means probably that your robot is still idling. And imitation learning policies are very susceptible to idling because they can easily get stuck if you have enough idling training data in it. But our robot only moves when you engage the button, so you can later easily filter your data set on when you actually engage the button and get rid of all idling that is unwanted, because maybe some tasks require you to actually idle for a time until some other task finishes.
Exactly. Yeah, so now comes the point where, I mean, I will just collect some data. This is not going to be the most interesting part of the stream, but
So you're collecting them in one data set or in many?
yeah. So this task, it is kind of a loop. So I'm just collecting a longer demo now with multiple picks, but I will still every once in a while stop it and like move slightly like the scene around so that it's not too fixed on learning the edges of or the hard-coded position kind of the thing. So yeah, that's why I will collect a couple loose demos. Plus also I will have a couple so that it's easier to split the validation set out of it. Yeah, so I think this will take about 20 minutes.
Yeah, so the important part about data collection is to kind of have a structured approach to most of what you're kind of doing. You need diverse demos, but not too diverse, because you do want to learn variations, but you do not want to confuse the robot with contradictory operations. So the best way is to unambiguously teleoperate the robot for the task. So avoiding kind of motions that need a lot of kind of branching parts. Like the methods now are better at dealing with multimodal distributions, and they will learn something. However, the more branching kind of factors you have in your data set, the harder it will be for the model to kind of commit to one, because especially if you have that over multiple time steps, so your look back of 2 frames doesn't actually disambiguate which path the robot should take and learn. So yeah, it is good to vary the environment, split the demos, and see that
Thanks.
you get some nice variation in there. It's always hard to predict how many demos you want, and also the absolute number of demos is pretty meaningless, like, because we can collect a longer demo that actually has multiple dunks in one demo. So if we have like, oh, we only have 10 demos, that's not really meaningful. What's more meaningful is the time that in the end goes into the training. So how long the process data sets are, and not how many absolute number of demos you have.
Yeah, I did start to record them all single just so that we have somewhat of a counter of
how many dunks. Yeah.
I think that's more satisfying.
Yeah, so here the saving is not directly to the controllers. You can also use the GUI to press the buttons manually, or you could map it to the paddle or another input device. It's really up to you.
Maybe you can show what the pedals actually are.
Yeah, right. That's a good part to explain.
Yeah. Because, I mean, we are using a hand, sure, but I mean, it's basically a glorified gripper with how we're using it here. But it is possible to do like full-on hand tracking. The issue you get then is you don't really have a way to...
Yeah, how do you engage? Like,
yeah.
So if you have the controller, if your hand is your controller, you don't have a button to actually say, now follow the movement. You can have a second guy sitting there, or, well, you use something like paddles, and you do the engage button by stepping on one of the pedals. And that kind of makes you even possible to do dual arm, 2 hands tracking, and engaging them with the left or the right foot. These pedals are just another peripheral that is easily integrated into our stack and can be used for also whatever you kind of want to use it. You can also put it to the recording and stopping if you want that. Nice, thank you. Some variations. So this, in this task, there's really no need for pedals. But if you want to have really human hand tracking, and map the finger especially to a more dexterous hand, then it's very much recommended to use the engage button from the pedals and not from the hand somehow.
Yes. So yeah, I mean, this this is just something that will take.
So, but we're already training now, and
collecting
1 hour 5 minutes in collecting the data, and that is just in the moment a necessary step. Like, so it really depends also for what kind of method you want to collect the data. But again, we are quite agnostic to that. That's also why it's good to collect the data and as high fidelity as possible. Even if your method doesn't actually use it, you can always toss it away. But it's very, very hard to regain anything you didn't record. So we are recording at 30 FPS of the camera, but in this example, we will actually only use a 10 Hertz of it.
Quality, yeah.
So we will gonna toss out 2/3 of it, but it's still good to have the 30 Hertz because another method might use 30 Hertz instead. And then it's good if you actually did collect it at that fidelity.
Yeah.
So it's also useful to define these routines to the go home position to just avoid resetting the robot. We are controlling it Cartesian. It is a 7th of robot, so you can actually see some drift if you would continuously teleoperate it without resetting it to the home pose, because yeah, that's how inverse kinematics works.
Yes, exactly. So yeah.
So you can vary different ways of the environment. In this task, we will only basically vary slightly the position of the ring. The ball is self-varying, so it's a very nice test of because you can run it afterwards, and every time you don't need to actually reset the ball, and you get very interesting states like this one as well, where the ball is actually quite difficult to recover. That can also be included in your training data. And yeah, if you are not happy with a demo, you can also discard it before saving it.
Yeah, it's basically another button on the controller or in the GUI. Yeah. No, it's actually...
It's going quite well.
Yeah.
So we can also see now we have 30 recorded demos, right? For how many dunks should we go?
I don't know, I was thinking 20 minutes of playtime. We started at about 1 hour in.
I think so, yeah.
So
let's have, yeah.
maybe we can get like 80 dunks.
Yeah, I mean, it's good if you save.
Yeah.
Each demo will actually have a dunk counter implicitly.
Mm-hmm. Yeah, exactly.
For that.
Yeah, so I mean, this is yeah, don't worry, it will get even more boring once the training starts.
It's even less to do.
Yeah. But yeah, that's when it's time for a lunch break. But I think we're actually almost even early for it.
Yeah, so we are from Sweden, so life-work balance is very important. So we a bit aggressive.
Yeah.
There, so we will train the model over lunch to not skip our lunch break.
Oh, that's fine.
Close dunk, yeah.
I mean, that one I could have maybe discarded, but
it's okay.
I'm a bit lazy. Maybe it's a little bit far away, actually.
We can move it.
The dunks, yeah.
Move it a bit closer for it.
Yeah, so thanks. So yeah, data collection, it is kind of boring. I mean, the first couple minutes that you're teleoperating a robot, it feels really fun and cool. If you've trained many skills, maybe you start wanting to rush it, but we have found that it is quite important to ensure you have proper data.
Yeah, so the data quality is really, really important for the performance of any of the imitation learning methods that currently are out there. And therefore, this is a quite important step to record high quality data and then also make it as easy as possible for the operator to do so. That's kind of also a point of this system, that you can easily save this card and also then later inspect without needing some over-engineered machinery for it. The performance is also quite important. So if you collect like data that is not as high quality, the performance of your skill will also degrade.
Like the robot cannot do things that you weren't able to do, so to say.
So, and
I hope actually that the all is not obscured. Can you maybe?
Yeah, it's visible.
Yeah. Okay.
It's a bit dark.
Yeah, maybe we should have played with the brightness parameters a bit. Although I think
the ball is visible.
Even with the thumb.
Yeah. It only takes it like half. It should be fine.
All right.
So yeah, also kind of the camera viewpoint, of course, is important. It would be a bit more better if the camera would be a little bit further on the side, not obscuring with the thumb. But I think for this task, we will be fine. It will still work reasonably well. We do actually have a workshop coming at RSS where we want to discuss with the community about data quality, like that the demos are a first decision variable in the performance of the actually policies. And while from an academic point of view, the method itself is more interesting, we're getting more and more interesting to actually deploy these techniques in industry. And there, the performance is all that matters. It doesn't really matter which method you employ under the hood, as long as you get to the 99.999 performance. And for that, data is crucial, and then you also have to collect and curate it at scale, which has its own challenges. So if you're interested in that, there is an RSS workshop coming up. You can find it on the website. It's called It's the Demos. Deeper look into this, the rule of the demonstration qualities. We organize it together with people from KTH, DLR, EPFL, and also from Australia directly. Nice variation.
To keep it interesting. I don't fall asleep. Oh yeah. That's fine. I mean, like, we probably could make a more flashy demo thing, but yeah, we wanted something that doesn't need too long of a training time and not too much of data collection time. We have, I mean, if you go to our website and check out the trailers or some of the other material on our YouTube, we do have quite some skills that we trained, like for fun or for papers, but also for proof of concepts. And generally we found that with about an hour to 2 hours of data collection, you can get quite some.
You get the first viable policy that you can use to kind of check out the feasibility and kind of how well this works, and if you should change your setup or your data collection strategy. So the iteration loop can be quite fast in this regard. And we also wanted to kind of, the point here is really to try to get an autonomous skill before we have to go home for the day, because again, it's good to have life-role balance. So the system you see deployed here really highlights that. It should be as easy and as kind of fast as possible for you to use it in order to collect any skill on any robot and with any end effector that you might have for your task.
Yeah, so let's see.
Yeah, 5 more minutes.
I mean, we're at 60,
60
so
demos,
that's
pretty good,
exactly on schedule, actually.
So, this is
20 per 5 minutes.
Nice.
Yeah, you're getting there. That's fine. More variation.
Yeah, it's also good to see it live, the data collection part as well, because that's also the part that that isn't shown that much, right?
Yeah.
How many demos and how easy or annoying it was, or how many grad students you actually had to collect this data for the skill that we see in a lot of videos. So I think this is quite nice to include this part as well, because yeah, it is really important part of any skill learning system that is out there and deployed, because yeah, it really matters, your demos. And right now, even if you can leverage pre-trained foundation model like Groot, Pi0, also you still need to fine-tune on domain data if your task is not literally what is in the pre-trained data. So the data collection, even if the effort gets decreased, is still an extremely critical point in any pipeline or any model that is deployed.
Yeah, I mean, we can elaborate a little bit on Groot training.
Yeah, the good part here, kind of this data, the data set, you can train different methods and then fast compare them easily on the same task to also see where are the strengths and weaknesses of different methods. Or if you just want to solve the task, you train a bunch of it and pick the one that works on that one the best. But the data collection effort is only once. You don't have to recollect for every single method under the hood. So this is very nice. The only thing you need is compute to actually train different policies or fine-tune foundation models or VLAs or other approaches after the fact with the same data.
Yes, exactly, yeah.
Oh, this 80 prediction was pretty spot on.
How far are we?
74 after this one. And we have 1.5 more
Okay.
minutes, 6 more dunks. I think that
Alright.
tracks.
Alright, now I want to make it as well. That's 15 seconds per dunk. Oh, start recording. Yeah, now I want to be fast. This is how I'm gonna poison.
This is how you're gonna poison the data set. You're gonna run the clock. 4 in 1 minute, yeah.
I'll stay calm. Still gonna be fine. Still fine. Oh, tough one.
I think you have the net.
No. Okay, this is 79 demos. It will be. Oh no, still on schedule.
We are still
on
30
schedule.
seconds for 2 more demos.
Yeah, maybe I started a bit before 1 hour or something then.
We will see in the recording on the vote. So 1 more.
All right.
Okay,
Easy.
great.
Yeah. So yeah, as you noticed, I was wearing the headset on my head. I wasn't looking through it, The reason is really just to have the cameras track the controller.
Yeah, it's good to
but once you have calibrated, there's no need to see what's going on in there.
Yeah, no need to go through it because the depth perception through the headset is actually quite worse than you realize. So we always write normally on the head.
Yeah, let me now check. What do we have next? Yeah, you can see they're going over the Okay, so we've recorded. Yeah, again, like we have here now all the demos.
Yeah, so it's a bit more than 80 dunks because the first 3 demos have multiple dunks.
Yeah, that's fine, I think. Okay, so training is quite simple. Just use INCAR train with a config path. Nice. But here's an example config. I will walk you through it. Don't worry. So yeah, this config can be really anywhere. I will just put it here, just so that we have like we keep it in the workspace. So what do we need to define? Well, our workspace is located at stream workspace. I want to save it as basketball, and the dataset name is basketball. Note I also edited it here as a raw dataset, and it will save a pre-processed version here. This is just so that if you train multiple policies on the same dataset, you don't have to do the pre-processing every time.
If the pre-processing is the same. If you have different pre-process, then you should have it as a different name, obviously.
Of course. Yeah, so let's see, the type we want to use the fusion. Again, like there are ways to have your custom policy. I mean, this is a slightly more complicated interface, but it's quite well documented. And then you can train and run inference on your custom policy. We, for example, also have a GRUT integration which uses this interface. Took me about half a day to set up that interface. So, like, obviously, if you want to do things that haven't been done before, you need to do some integration work because we cannot predict everything. If you find roadblocks, then we would love to hear what is making it difficult to do something you would like to do. But generally, yeah, things go quite easily with these extensions. The fusion already exists. We don't have to make any extension for it because we've made it before. Let's see, training a policy. Yeah, so we have the fusion. We will run it at 10 Hertz, and as input features we will take, again, wrist cam is a visual feature, arm pose, gripper joint position. We don't have gripper joint positions, though. We have hand joint positions, and they have a size of 6. I don't think we
don't really need this.
Anything else.
Like, I think this is this is the input features. So we have the wrist cam, we have the end-effector pose.
And we have
there's no need for the joints. We could also add the force and whatever sensor you want, but for this policy, this should be more than enough to learn it.
Let's see. Then we have our output features, so the actions we want to do. We have the end-effector velocity action. Again, like these features, they are. Oh, let me close this. You can find which features you have going in and out of your system here. Basically, you just need to match those, or you can check in your dataset config which features are in your dataset, because obviously you should have the features in your dataset.
But here again, you can have recorded more features and then not use. For example, we did record, I think, the joints and the effort of the hand, and we will not use it now as an input, and that's fine.
Yeah. So yeah, we will control by gripper open close, and I will add one more because we also have routines. So write.routines, you can see it matches here. Action shape 1. Then what pre-processing do we need? We want a small.
Reduce the ratio.
Yeah, we can reduce it.
Yeah, because we are gonna train over lunch, right? We'll do 10.
Yeah, sure. So first we start with sampling the dataset to the DT, because the video is in 30 Hertz, but the joints might even be in 100 Hertz or whatever frequency it came in at. So we will make sure everything is sampled to the same time step. Then we will downsample the video. I think that's also a fair step to do. Actually, we had the same feature name, so just can, because I mean, we don't need that high of a resolution, and then it just trains faster and potentially with less data. I'm not sure actually. This is also a good step, I think, filtering by the buttons.
Yeah, this is basically the idling we were mentioning before. So here basically everything that isn't active and the button grip value, which is this site engage button.
Yeah. So this way we filter out the data of when I was actually moving the robot. And then image transform. This is like to do some jittering and stuff. I think that's also good to do, to try and get a bit of robustness into the policy. Not that when the sun starts shining, we lose our performance instantly. So you might wonder like that this is a bit of magic keywords and hocus pocus. I mean, these are types that come natively with the system, but this is basically the same as these extensions, like for the basketball pose. The difference here is which hooks we are using. So if you remember here, we have teleop command hooks, inference command hooks, but we also have hooks for like pre-processing the dataset, for when you get a sample from the dataset, like the jittering, for example, uses this hook. There's hooks for prior to observations, and that makes it quite useful so that
for some reason, if you would like to have a pre-processing step just flipping an image or so, you would write a very simple extension that hooks into the dataset and the inference hook and applies the rotation.
Exactly. And a good example is the downsample video. You want this to be consistent both during training and during your inference. So this step uses like one function, but it's hooked into 2 points in the pipeline, and that way you can ensure the consistency. But yeah, again, in the documentation, we have quite some documentation also for the data flow, some examples, and yeah, you can process, like there's some example here for how to have a process step. I don't know what the example is doing anymore, but anyways, if you are interested, you can just take a look at the documentation. Anyways, I think here batch size, number of workers for the data loader. I will just save it kind of frequently and validate every 1,000 steps. We will see how long the lunch break is when we get there. But then let's see. So, getting started, training policy was quite simple, as we found. INCAR train config path is equal to...
Put it in policies.
Yeah, stream. I think this equals should not be there. Policies, training JSON. All right. Now we just get a confirmation of our config. Yeah, I mean now it's processing the dataset. So basically,
To
Let
make
me
this
actually,
bigger.
yeah, I will make this the main one. If I can. Hello. If I can do this.
A bit bigger, yeah.
Yeah, so it's now going through the steps. So yeah, sampling DT or AT.
It's also going through them in order. So if you, some steps are important to do before other steps. So the order of your pre-processing does matter. And if you hook in somewhere another kind of, maybe a mask detection or some semantic step or something, it's important to put it where it makes sense, obviously. For example, you want to have it on the downsampled video because that's also kind of where you would want the mask drawing inference to be detected on object detector. So then you kind of put it on the place in the pre-processing steps. Now we are at sample DT, right? Still, yep.
I'm wondering, should we pet the routine?
We should.
Yeah. So.
Yeah, there's actually one thing too that we should have,
Yeah.
that we added, which is not in the example, for the routines. So because the routines are actually very small signal, policies have problems kind of learning this specific signal, and they get a bit fidgety to kind of actually trigger the routine. But there's a simple extension to solve this, and this is of the type pad sampled routine. So basically, we do increase the number of frames in which the routine is active, even if it was only active for a single frame while we collect the data. Now it will be in the training data, it will be active for basically 2 before and 3 after on the write routines. Yeah, and then we just, because you forgot the comma at the end.
Where did I forget a comma? Ah, here.
So now that this part is...
That sampled routine. I didn't... Okay, maybe I misnamed it. Let me check actually, and maybe this is something that should go more clearly in the documentation, because I'm not sure. That sampled signals. Yeah, alright.
Yeah, I think that's a good point to add to the
Okay.
end steps before is not there. Yeah, because it's pad steps before, not end steps before.
That. So that, and this is actually signal feature name. Alright. Yeah, now we're going. Alright.
Found it, and now we're gonna sample it here. So we're gonna check the process data set real quick before we go to lunch and let it train, just to see kind of how it what it cut out. And basically, you will see in the video how it is downsampled and how it is has only basically more or less moving parts in there, and no longer all the recording.
Mm-hmm. Exactly.
So of course, this step depends very much on how much data you have, how fast and how slow it is, and the same for the training afterwards.
Yeah.
We are training on 5090, which is pretty decent for most parts.
Yeah. I'm swapping to camera view again. Yeah. Also, what also is a thing is which video codec you are using might change. We standard use VP9 just because it's you don't need any external dependencies for it. But if you have a faster codec or some hardware-enabled thing, then this processing basically just speeds up a bit. But I mean, for the small data set, it's alright, I think.
Not a big problem. So yeah, we can just have this open on the right to see the steps. So this is the workspace, the train config that we see. Okay, we are in the sample DT. Then it's gonna pad. Then it's gonna downsample the video. Then it's gonna filter. And then the pre-processing is done.
Yeah.
So yeah, what is actually the... it's 10 minutes to lunch. Very good. Very, very well on time. That will be perfect. And then we will be basically seeing the training. We're gonna train it probably like for around an hour.
Yeah.
See what
we can look at the loss a bit.
Yeah, to check where it is. So of course you can train longer, but we do want to show this like in a timely manner. The performance might not be as great with a shorter training, but the point will still stand about because this is just that time that you can just run it longer. And normally what we do at INCAR is we do train it overnight. So we queue up our policies we want to train for the next day overnight, and then they have more than enough time to finish, even if they are training on bigger data sets or training with foundation models or similar. So there's really no bottleneck there. You cannot do it on the day directly, but on the next day you can then evaluate and iterate over your method policy and see. So pellet samples was like that. And now we are downsampling the video, which will take another 4 minutes.
I think faster because the first videos had
the first one that's true. The first videos were longer, and then it's like 15 seconds towards the end per demo, so not a very long horizon here.
Also, I mean, let's see. I think after that we just filter by the buttons, so
that should be fast.
Yeah, I mean it's fourth of the number of pixels, then but maybe I can, or I mean I will do that in a bit. Maybe I can elaborate a bit on crude and alternative
methods.
policies,
Let's look at the data set first.
Yeah.
And then we can just show in the examples what is already there. But this is an always expanding catalog of methods. And also it's very easy to write your method basically as an extension and then add that to your paper or to your SharePoint. And then other people, labs, research institutes or whatever, can take these methods easily integrated into the system. And of course we are gonna see what's really nice methods we want to put in the system. But again, the community can heavily influence which methods are available here as baselines. And then you can also show that your method outcompetes other published methods in a very structured and fair comparison, because the implementation will be the same as the other lab is using in the real world, which brings, it's quite a benefit to show it on real hardware that your method actually outperforms other methods, and it wasn't a contrived example for that, or maybe just because the implementation is subpar, because obviously every time if it's your method, more effort goes into optimizing and performing than implementing baselines, and implementing baselines is really annoying. Speaking from experience here.
Yes. Yeah, so it's
also we are training, so that was around 1 hour 40 until we get to the train. That's not too bad, and we also saw that we didn't really rush ourselves too much. So this can clearly be done faster, but I think it's a fair representation because again, you shouldn't speed run your showcase.
Exactly.
It should be representative of how you actually work, and the work is not done by always being super fast.
Yeah, and I mean, we know how the system works, of course, so we get a benefit, but we do expect that we can have like quite a, that anyone can do this in a day, basically. So, yeah, I mean, now we have it processed.
Dataset is there, so we can look actually into it.
Yes, so, this is the wrong one, here. So we now have basketball and basketball validation. The validation is just a validation set. Basketball is the rest of the data. And if we look now at, for example, the wrist cam, we can see it's lower resolution and it's downsampled to 10 Hertz. Yeah, basically that. We can look at the routines and maybe see that they are now a little bit padded because they are not just one sample anymore. Probably those are the
main ones.
The main ones, yeah.
But so again, you can then reuse this pre-processed for different methods, or you can generate another pre-processed one to compare pre-processing methods as well, quite easily. And kind of, all that's left kind of now is to actually train the policy,
just so that the loss is
happening now. And probably going to train it for around 1 hour.
Yeah.
Maybe before going to lunch, we can say a little bit about the other methods.
GRUT. All right. So this changes now that it's smaller. So yeah, we have as examples, we have also GRUT. I think this is also a good example of we collected some data like months prior to GRUT being tried out on visual motor diffusion, what we are training now, and we noticed that it is very dependent on lighting conditions. Like you open the curtains, let the light in, and it just stops functioning basically. So we had this data, and just in like 10-15 minutes retrained it with the same data, but now with a GRUT config. And now it didn't suffer from this anymore because GRUT has so much pre-training on different lighting conditions and stuff. It can generalize to.
Training of GRUT itself wasn't 50 minutes.
No. But I mean, my work for it was 15 minutes to start it overnight. Yeah, good to mention.
But, like the GRUT itself does train quite for a while.
The
fine-tuning takes quite some time.
Exactly, and you can see even with like a blue liquid now, which wasn't seen in any of the training data, it could do it. This is, I think, a very good strength because it's not, we have a new method. We need to rebuild our whole pipeline for data collection, storing, training, and running inference. This was like a small config swap. And I mean, I did write the extension for GRUT as well, which took about half a day because I was the first to do it. Basically, here is the difference. Like, you just change the type to GRUT, and GRUT comes with a prompt, so you add the prompt, and it has a different dataset representation. So we have a step in our pre-processing that converts it to the right dataset structure. We can actually.
I think one thing else to highlight is for the academic part of kind of method comparison. Like for example, the S2 baseline that we did. It's also here as an example. That was a semantic spatial diffusion work that we did as well with collaboration from KTH. And here it's kind of having a semantic mask and any depth model producing from the RGB image, producing a semantic and a spatial image that is then fed into the vision motor diffusion. And here, for example, it's really nice to kind of see then, okay, if this is available on this as a policy in the system, anyone can easily deploy that as a baseline and outperform and improve on it straightforward without having to re-implement from the paper or from suboptimal code. And if the implementation is available, other people could re-implement this and say, oh, there was actually a bug, and fix it, because all of those parts are kind of as extension, can be publicly hosted wherever you want.
And as you can see here, training this is basically adding some processing steps that can do the segmentation and the any depth, and then combining them in different channels, and like that is literally the the whole thing. And again, this one we have implemented, but we can look at the code a little bit to see like how difficult this actually is. So yeah, for the S2 we have like a depth anything step, which here does a depth anything. We have a grounded SEM step, which is like just a bunch of code for the grounded SEM, and then we combine the channels, which again is a little bit of code, but the point is this is the only code. There's no need to do any robot integration again, or load it in, load all your networks in specific ways when doing inference. Same for GRUD, kind of. So this is just from NVIDIA, like the GRUD stuff. I mean, this even has the the comments still in there from the template of the extension, and this is basically just an adapter of how to feed in the observations to a policy server for GRUD. You write this once, and now it's super easily usable. And again, you only write this extension. It's not that now you have to rewrite your whole inference pipeline to run a GRUD policy on hardware. Like, you only need to set up this interface. And again, if you have any issues or difficulties implementing anything you would like to implement, then please let us know, because it should always be as easy as possible.
I think with this, it is lunchtime. It
is kind of lunchtime. Also, diffusion, for example, is also
it's
implemented the same way. Basically, diffusion just is a standard offering. The INCAR baselines is installed just because we want you to be able to start out without having to install extensions right away. But yeah, that is it. I do think maybe it is just lunchtime.
Yeah, I think it's lunchtime. We will leave the stream running.
Just so
basically come back. Yeah. We will mute it though, so we can go to the OBS, I think.
We can
do
All right, we should be back now. So, yeah. Let's see. Oh,
See how much it trained.
it trained. Let's see. We are at step 40,000. Oh, just now, actually. I think that's good.
Works. That's how it works.
All right. Then I will just stop this training. And I mean,
Yeah, okay, obviously we only trained it for 40k steps.
which is quite short.
So it's kind of short, a bit more than an hour.
But we can see how this goes. So now basically I open the skills panel. We have our basketball skill now. I will just load the last policy that we have. Ooh, very nice. Wow. All right, and I will reset this. It seems to have disconnected. Which maybe the headset went to sleep. Possibly, but the robot is still there, so. See. Otherwise, I just restarted. Seems like something happened, but that's fine. All right.
And it's back.
Let's see. Prepare connection. Now we are there. I will just calibrate the robot again. Okay. Yeah. So connect to the robot. We open this connection. Let's see. Alright, loading the basketball skill. Again, we have the video here, and we just trained this. I will load actually.
Are you ready to
last policy? Yes. And let's see, so I can control it. And now the policy can control it.
So now we are fully autonomous. Trying to catch the ball.
Oh, I guess it never saw this position of a failed grasp. So, I'm not doing anything here. This is the policy. First
dunk. Sub 3 hours achieved. And we can now see this is an interesting case of like where the policy encounters a state that's out of distribution because it hasn't actually seen the closed fingers when it has not picked up the ball. Like it's this state where then it's good to kind of take over and correct this behavior and collect these demos for the next iteration of the policy.
Actually, I will send it home. Just to. So yeah, like now I can take over and do this. What I can do at the same time is start the basketball one, and you see it turns red now because I'm taking over. I can do whatever I need to do. Let's go again. Policy takes over seamlessly, and this is now extra demonstration.
And we also see that the policy triggers the routine, so it does trigger itself to go back to home after the dunk, not between attempts of tossing the ball.
I will say it's
so the performance
not doing very well.
is not so great. We can randomize a bit to see how it behaves.
So.
We can also see that a lot of times it always hunts from the start of the policy and needs still quite some help to correct for the motions.
Okay, yeah, this is.
And all of these kind of corrections are being taken into the new data set. But that was unfair.
Yeah, I'm thinking what we can also do is to just train it more.
Yeah, I think at this point
this is not great.
we can also try the best checkpoint. So because we can easily change the checkpoint, maybe the 40 was just a bit unlucky, just to see if that
Alright.
Helps.
I do best. So this reloads automatically. Yeah. So yeah, you can see like it's kind of learned something maybe.
Performance is not at like satisfactory level yet, but we can clearly see that it is getting. It has learned to go to the ball, but it clearly has not learned any error recovery where it could kind of deal with out of distribution states, because in all of the training samples it never actually picked up the ball and then lost it. So it doesn't actually have any notion of, and it doesn't pick the ball up perfectly to reattempt, and it now kind of tries to.
Yeah, but I think what we could do is just resume training and check back in another 1.5 hours. Like,
Stuff, yeah.
But why not?
Let's do other things.
Yeah, I mean, we don't have to sit here.
No, the camera is fine. Yeah. So we can resume training to 100k. See the difference if that is the culprit, or if it just does need more training examples of states that it is struggling with. But for now, let's resume training.
Yes.
And wait until it has the 40 the 100k training steps that it's supposed to have.
Yeah, and what I can also maybe show is we had some takeovers, right? So here we have our first takeover. So this was an autonomous policy that I think here I started during. I made a correction and the policy just takes over. Here, fingers were closed. I take over here, move it back, and policy takes over. And this is how you can make small corrections. Yeah, and that the policy can then learn from. But yeah, this was a bit optimistic. Preprocessed dataset true and resume true. I hope those were the correct things. Seems good. Yeah, and then basically we will just do some other things we have to do, but
Yeah,
we'll be back
after the training is done.
Yeah. All right. Let's see if that policy
Does
better.
Exactly.
Yeah.
Okay, then let's.
All right. right. Let's see if the sound is back. Did it? Yeah? Okay. Yeah, so I mean we're back a bit earlier than we said.
All right.
But that's because we reached early stopping, so did not detect improvements anymore. So let's see how this policy does.
So again, we can just select the new checkpoint.
Yes, let's see, this is a bit big. Well.
In the init. So
Yes.
randomize a bit.
Let's see. I will reselect. Let's load the best one, and then we can see if this is the best. Let's check.
Oh.
Yeah, I'm still connected. And then I will swap to. I think I swapped to. Yeah.
Yep.
Okay.
Great.
All right. Let's play the policy. See if it managed to learn it.
A bit dangerous.
Yeah, I took over there.
Good. Yeah, we have to save the hand.
Yeah.
It's not good to break it.
I mean, we played with it for 20 minutes, which is not that long.
Yeah, of course, like more training data is probably gonna help as always, especially if it's now, for example, we see the case where it does sometimes not correctly grasp the object, the ball, or it slips out, and then it has to kind of.
Also, just try the last checkpoint.
Is that position a bit off or
No.
too much?
I don't know, to be honest.
Oh, okay. I mean, so this is like with this little training data. It seems that's the performance you can access with the diffusion method right now. We can randomize this a bit to see if there is a more favorable in distribution training state that it does like more.
I mean, this is doing it live, right?
I mean, but that's also how to see, like, so there are different methods that you can train and then compare. Again, this is the most straightforward vision model diffusion based on RGB images and the proprioceptive information.
But like, I think the issue actually we have here is that the ball
we don't see the ball.
is not it's not really visible.
On it. Yeah, it goes for it when.
Maybe we've just been self-obstructing. That could be. Yeah, I think here it's not gonna see it again.
Oh yeah, it's really exactly in the blind spot of the hat. So yeah, obviously the policy is not magic. So if it doesn't see the ball, it cannot possibly grasp it.
Maybe we should have taken care of this during data collection.
Yeah, but that's okay. Like, yeah, we can. It's a very nice
that's
explanation. So that if the ball is on the left side, it should have a much higher chance of actually getting it than if it is on the. Yes, if it is on the right side. So if we keep putting it on the on the right side of it.
Yeah, now you also.
So that's another thing, like in all training demos, it always started from up here and went directly to the ball. It never followed the ball in any of the demonstrations. So therefore that part of the skill is not is not covered. So while you're from the home, it has a better chance, still not as robust as one would have hoped, but now one could kind of try to train another method with the same data and then observe if the other method succeeds more or less with imperfect demonstrations, or if one is more output performance oriented, then one could try to collect more data, collect more cases which it now fails, see where this is. Yeah, it's really, this one is really hard to see for it. Now I just saw it a little bit and was able to dunk at least 2 times. It also seems to always roll onto the other side.
Yeah, maybe the table is crooked. Yeah.
So there is, but as we can see, the policy does run suboptimal, but it does work only in 4.5 hours. And of course, we can at this time, if we would spend probably 20 more minutes collecting, the result would improve. But we already have some successes here, even some successive successes. So if we report that for an academic paper, we can already benchmark the performance of it, and now could develop other methods and other processing stuff, making it more robust to occlusion, making it more robust to outlier in the training data. All these kind of ways are possible to easily build into the stack and system and extend it yourself.
Yeah, I would also say I don't know how it's noticeable on stream, but the sun has started shining.
I mean, now
So
it already had now, like this was 4 in a row, so that's not too bad. Of course, we would like to have it
100%.
100%, but again, this is also when you do it live. So now we can make a video of just the successes, and then it seems like it's always succeeds. But of course, that's not really informative of it. So let's reset. Sorry.
Oh yeah.
That was unfair.
Reset.
To it. Yeah, this corner is really blind spot. This is really interesting. So that's another thing to lesson learned of it. But yeah, we cannot see the ball if it's on the other side. Now it's visible, and now it does go for it. So there's clearly some learning, but we can also see that it does not fully
understand
the task yet with the bit more than 80 dunks that it got. And now either we could collect more principal demonstrations, or we can collect more takeover demonstrations that only fix particular failure cases. But for example, this obstruction of the ball that we are running into now clearly suggests that we should actually move the camera slightly to have another view on the field. And these kind of insights can be iterated in quite a fast manner thanks to the system. Because now we have this saw this obstruction. This can be fixed with changing the print. We still see that when it sees it, it does indeed dunk the ball and is able even to do some consecutive dunks. Again, this part, not in the training data, is a clear limitation. But overall, I think we can be happy with it and give the robot a rest. And with that, we can also
end the stream.
And
yeah.
So
I mean, if you're interested, go check out the website.
And see.